Good morning students. Today we are going to see a case study on partial differential equation. So what do you mean by a partial differential equation? So a differential equation which involves partial derivatives, that is one or more partial derivatives, is called a partial differential equation. So here we are using some notations P, Q, R, S and T. So P is nothing but dou U by dou X and Q is nothing but dou U by dou Y and R is nothing but dou square U by dou X square and T is nothing but dou square U by dou Y square and S is nothing but dou square U by dou X and dou Y. But today we are going to see the real case study of our problem, and this was conveyed by our student Sudarshan. So let me tell you a story and go through this case study.
Good morning everyone. Today I am going to give a small story of the cooling coffee cup. So imagine that you pour a hot coffee in a room. At the beginning the liquid is extremely heat. Now that liquid is starting to go at the end of the room. So now what is the temperature inside the coffee cup and outside the coffee cup? That varies gradually according to the room temperature. So now we want a model how to predict the temperature changes from both of the coffee cups and the surrounding. So for example, when the coffee cup reaches 50 degrees Celsius, how long it in the coffee and how does the temperature of the air and the cup surface will changes gradually. To answer this kind of question, we need a differentiation equation of heat equation, which is the fundamental partial differentiation equation used to understand the diffuses through the material and the environment. Thank you.
Very good, Sudarshan. So Sudarshan explained a problem. So for this problem, Ritik Roshan, you are going to give the difference equation.
Now I am going to explain about the heat equation. In mathematically, we describing temperature of function u of x comma y, and in 3D we describe as the u of x comma y comma z comma t, where u and u of xy is denoting the location and t is locating the time. Now it is called as the heat equation, or describing also a diffusion equation. Now I am going to say about the equation. Dou u by dou t equal to d of del u.
Hi guys, let me explain about that heat equation. Delta U for Laplace operator and D for diffusion constant. This equation states that the heat flows from the higher temperature to the neighboring cooler regions. Thank you.
So very good, Pradesh and Ritik, you have explained very well. So now the problem is going to solve by or explained by Subhashri. Okay, Subhashri, you can explain the problem now.
Good morning everyone. Today we are going to discuss about how to solve the problem. Based on that assumption, there are two methods. One, analytical method and numerical method. First we use the analytical method. It is some simplified geometries. For example, 1D rod and infinite plane plus Fourier series work. Next we can use the geometrical method, discrete space or time of approximate derivatives. For example, finite elements and infinite differences, stepping forward in time to simulate the process. Thank you.
Yeah, ma'am. And guys, in every problem there are outcomes. The first outcome is in a temperature, it will be decrease or increase in the time scale, the temperature time scale from 90 to 60 degree in minutes. The coffee cup also like that. The second outcome is in initial room. In a room, initial temperature is not having equal to the next after some several minutes. It depends upon the room temperature, it will change. The third outcome is if you in the cup in the class, in the cup in the room, whatever it is, the cup material will change like a thermos. It will be similar to the environmental matters. That's all the outcomes. Thank you.
Hi guys, myself Praveen Kumar. I talk about the summarize of heat diffusion. Heat diffusion is nothing but temperature decreases due to air surrounding or material of insulation of the cup or other materials. Heat diffusion, how can we find heat diffusion? By using mathematical calculation like partial differential equation. By using that we get a equation. For example, y equal to mx plus c. This is the equation. Tell about the slope of straight line. By using this we can vary the decreases of temperature from the material or insulation of your cup. Other than the rate, how can we define? Rate is depends on the environmental surrounding or material of the cup or other room temperature varying from the method. Rather than we can see by changing the heat diffusion we can remain the constant or heat with the same by using the changing position of the room temperature or cup of the material or exchanging the drinks we wear it on the cup. Thank you. That's all.
So hope you understand this case study. So using a simple cup of coffee, we have derived this case study using a partial differential equations. Okay, thank you students. Thank you all of you.
Thank you, ma'am.